All right, so in this video, we want to find the equation of this sinusoidal function here, and specifically, we want to find the sine equation. So you can do either sine or cosine for these kind of trig equations, but the question specifically asks us to do a sine equation. And we know sine equations start at the axis, but they start by going up. This one starts on the axis and it's going down. So we can actually make this a negative sine function and start it over here. We can make this the starting point. It's a negative sine function now. And we don't have to apply a phase shift. You could have also picked this point as the starting point for a positive sine function. And then you could have used a phase shift as well. If you want, I can probably end up writing both equations, but either one should get you full marks in the question. So the first thing we want to do in this question is we want to find the amplitude. Pretty easy to tell the amplitude over here. From here to here, the distance is a distance of 1. If you want the equation, amplitude is max minus min divided by 2. My max is 2, my min is 0, and I'm dividing by 2. Just 2 over 2, which is just 1. My equation of axis, which is the center line of this graph, you can tell it's 1 over here, but if you want the formula, it's max plus min divided by 2. And that's going to be 2 plus 0 divided by 2, which is also going to be 2 over 2, which is 1. So y equals to 1 is my equation of my axis. My period for this graph, if this is my starting point, this is 1 full cycle. My period is 2 pi over 3. And then to find k is equal to 2 pi divided by a period, which is 2 pi divided by 2 pi over 3, which is just a k value of 3. So now we can write our equation. Remember, the equation is y equals to a sine k x minus t plus c. And remember, I'm going to do two versions of this equation, one pretending like this is the starting point, and the other pretending like this is the starting point. So let's start over here as this point over here being the starting point. I know this is a negative sine equation. So I have y equals to negative. A is my amplitude, and I found my amplitude to be positive 1. So I don't have to write it down because a 1 just means you can just write sine because this is exactly a 1 over there. My k value I found to be 3. There's no phase shift because remember, I'm starting right here at the y-axis. And then my c value is my equation of axis, which is also 1, so plus 1. You have to write this over here because when you're multiplying a 1, you don't have to write it, but when you're adding a 1, you have to write it as well. So that's the equation for this function over here. But like I said, let's also pretend like this is the starting point now. And let's do a second equation over here, pretending like this is a starting point. So this is going to be a positive sine equation because it's going up, but it's on the axis. So y equals positive. And then the amplitude is the same. It's still 1, so I'm not going to write it down. And then I have a sine. My k value is still 3. That does not change. And now I have a phase shift. This is phase shifted pi over 3 units to the right. So I'm going to have a d value over here, which is pi over 3. And then the equation of axis doesn't change. It's still y equals to 1. So again, you could write either of these two equations and you would get full marks because these two are both identical. They're basically both the exact same function over there, just represented in a slightly different way.